right, so you are in your position and velocity notes. You're turning to, we just have 2 left. 2 left, number 4, correct. Okay, so number 4 is kind of a review of all of it, then we're doing a graph, and then you know everything you need to know to do your homework. So, look at the question. It says, suppose a particle is moving along the x-axis. Okay, x-axis is important because it tells us we're moving left and right, not up and down. So, x-axis. What is position measured in? Feet. And what is time measured in? Okay, part A. Find the average velocity from 0 to 2. Now, velocity is a slope, but remember there are 2 kinds of slopes. There's the slope at a point and the slope over an interval. Which one are we doing here? Interval, because it's not at 2, it's 0 to 2, right? So we need to do the average rate of change on 0 to 2. So we would do x of 2 minus x of 0 over 2 minus 0. So it's still the slope of position, but it's your slope formula versus taking a derivative. Okay, we are going to plug in 2. You're going to do it over here to the side. So that'd be 2 cubed minus 9 times 2 squared plus 15 times 2 plus 2. 2 cubed is how many? 8 minus, this is 4 times 9 is 36, but then I have a plus 30 plus 2. So then if I combine my negative 36 with my 30, that's really an 8 minus 6 plus 2. 8 minus 6 is 2 plus 2, which is how many? 4. So 4 minus. Next I need to plug in 0, but I'm not going to show my work on that. 0 plus 0 plus 0 plus 2 is 2. So I'd have 4 minus 2 over 2. Now, before we keep going, let's include units. The top is x of t, or position, measured in what? Feet. What's the bottom, time, measured in? Seconds. So then if I have 4 minus 2, that's 2 feet per 2 seconds, or 1 foot per second. Okay? So the average rate of change from 0 to 2 is a foot per second. Okay, let's go on to part B. It says find the velocity at any time. That's a derivative. V of t equals. Remember, you have to state what you're doing before you do it on the AP test. So I'm taking the derivative of x. What's my first term? 3t squared minus 18t plus 15. Now notice that at any time means that you're going to leave it as an equation. Okay, part C says, is the particle initially moving towards or away from the origin? You need to check 2 things. The velocity and what else at that time? The position, because it matters which way I'm going and which side I'm on. So initially means what time value? Initially means 0 seconds. Okay, remember, initially means at the beginning. So I'm going to find x of 0 and v of 0. Remember that you do have to check both of those to fully answer the question. So x of 0, plug it in. What do we get up here for x? 2. Next I'm going to plug into v, which is here. 0 plus 0 plus 15 is 15. So if my position is positive, which side of the axis am I on? I'm already on the right because I have a positive position. And then which way am I also going? Okay, look at your signs. Positive and positive. So I'm on the right side. And I'm also traveling right. So if you want to, draw a number line. I'm at positive 2. Here's 0. 1, 2. There we are. And then we're traveling to the right. So are we going towards or away? Away. Therefore, thank you. away from the origin. Okay? Alright, now, if the particle is going to change direction, remember that it's velocity that tells us direction, so we need to do a first derivative test. First derivative test. So, set your derivative, which is here, equal to 0. You have to set equals 0 on your paper, or you're not going to get points for that step. So, 0 equals, and then what can I take out of this chunk? 3. So that'd be t squared. 18 divided by 3 is a 6t. 15 divided by 3 is a 5. Then I need numbers that multiply to positive 5 and add to negative 6. What could I get? If I do this, I'd have to use both negatives, yeah? So it'd be those guys. So 1 times 5 is 5, and negative 1 minus 1 more is negative 6 in the middle. So my critical numbers are t equals 1 and 5 seconds. Now, does that mean it changed direction because your velocity was 0? It could have changed direction, but you have to do a sign chart to see if the sign changed. So these are considered, if you were gone yesterday, points where the particle was at rest. It doesn't mean they changed sign. You have to actually do a sign chart. So let's do it. Another thing that we talked about yesterday is that when you do a particle line test, you have to start at 0 because time can't be negative. So 1 and 5 go on my number line. And then I'm going to plug in 0 first. What's 0 minus 5? 0 minus 1? 2 negatives make a positive in the middle. Say I plug in 2. 2 minus 5 is negative, but 2 minus 1 is positive. So that would be negative. Then if I plug in 6, that'd be positive, positive, overall positive. So my graph goes up, down, up. How do I label it? Not F and F prime. X and V. Good. V obviously being the derivative, position being the original. So look at your number line. When is the particle traveling to the right? Which intervals? 0 to 1 and 5 to infinity. Now if they told you when to stop on the number line, you would do it. But since they didn't, we'll go to infinity. So 0 to 1, union. 5 to infinity, because v of t greater than 0. When is the particle traveling to the left? What interval? 1 to 5, because v of t less than 0. Very good. Okay. All of that look familiar? Okay. First derivative test, we're going to just skip that. We already covered it. Come down to your definitions. Okay, we're about to move to graphs of f prime, which is a graph of velocity, because remember, velocity is the derivative of position. So let's just review some definitions, then we're going to do a question on it. So when is my particle at rest? When velocity is what? 0. When is my particle traveling up or to the right in the positive direction? When velocity is what? Greater than 0. Now think about it. If I'm looking at a graph, how will I know when it's greater than 0? It will have to be where? Above the x-axis. Very good. So if you want to put a little hint here, okay, above the x-axis. Now that's only if you're looking at velocity, right? Okay. Next one, particle is traveling left when velocity is what? Less than 0, which would be where in the graph? Below the x-axis. Very good. So I'm going to put below the x-axis. Okay, my particle will be farthest to the right when velocity changes from positive to negative, because that's where I would have a relative maximum. Now, it could be the farthest to the right, because think about that's like forward, but it also could be a highest point. So if you want to address that here, I'm going to also put or highest. Okay, so if something is thrown in the air, it's easy to be like, oh, I'm looking for a max. But the farthest to the right is usually where people are kind of more like, what is farthest to the right? What about farthest to the left? That would be a relative what? Relative minimum. And that would be when V of t changes how? Negative to positive. Very good. Turn your sheet over. Look at the next graph. First thing I want you to do is label it V of t. It's a graph of velocity. Yes? Okay, so that's a good question. So up here, I should have justified. So look at part D again. It says, when does the particle change direction? Did we have sign changes at 1 and 5? Yes, right? It went plus, minus, plus. So I did not actually finish answering that question. So it's at rest at 1 and 5, and then it did change direction at both. And then because V of t changes sign. So remember that it's the sign of velocity that tells you the direction. So if you want the direction to change, you want to have a sign change on your number line. Okay, which we did, but I should have answered, so thank you. Questions about that? So the difference between at rest and changing direction is that for it to be at rest, it only has to be a 0. For it to change direction, it has to also have a sign change. Question, Jesus?
That means that x part is left at 5 or right.
Yes. Yes. Okay, so think about, I'm the particle, okay, pretend, and this is my number line. Okay, what do I do first? I go forward, then I go backwards. Was I just farthest to the right? Yeah? Then I go backwards because I'm negative, then what do I do? Did I have a farthest to the left side? Yeah? So like if it's going like this on the number line, farthest to the right means you went forward and then you turned around. Farthest to the left would mean you went to the left and then you turned around. Well, so it depends if it's a relative or if it's an absolute. For an absolute, you'd have to do a chart to see, is that turnaround point really the farthest I ever got? But you'd have to have endpoints for that. Okay? Good questions. All right, last page. This is velocity. When is the particle at rest? Okay, so we have to give exact values, and actually make this graph go up after that, sorry. Okay, you have to give exact values when the velocity was 0. When was the velocity equal to 0? At what points? 1, 5, and 8. Okay, pretend it says justify. What would I put? Because velocity was what? It was 0, right? Those are my x-intercepts. Those are my critical numbers. Okay, next question. When is my particle traveling up? Well, let's make a little line chart here. 1, 5, and 8. Notice I'm starting at 0 on the left side. Before 1, what was the sign of velocity? Was it positive or negative? Positive. Between 1 and 5, what is the sign of velocity? Negative. Between 5 and 8, what's the sign? And then from 8 to infinity, what's the sign? Positive. What does that mean that the position was doing? It was increasing, decreasing, increasing, increasing. So when was my particle traveling up? What's the first subinterval? 0 to 1, union. 5 to 8, union. 8 to infinity. Because velocity greater than 0. Now, let's talk about something real quick. Could I say 5 to infinity if I put that velocity is greater than or equal to 0? Would that be okay? Yes. But if you're going to squish it all together in one subinterval, then you would have to say the velocity is 0 or positive. And you're allowed to do that, but you have to put a little equal to on that guy if you want to group it all together. Make sense? Okay, second part, when is my particle traveling down? 1, 2, 5, because velocity less than 0. Okay, now I did not label my sign chart. Let's label it. What should I put on the bottom? V of t. What should I put on the top? X of t. Okay, letter D says find the relative minimum and maximum position. There has to be a sign change for you to have a max or a min. At 1, is there a sign change? What direction? It's positive, then it's negative. So think about a positive slope to a negative slope. What did that outline, a max or a min? Max. What about at 5? It changes from negative to positive. That's a min. What about at 8? Neither. Very good. Now, you also could see it actually probably easier in our line chart, right? Max, min, neither. Okay, so let's write that out. My relative minimum in position, remember that's also sometimes called a local minimum, is at t equals 5 because velocity changes negative to positive. Then for my relative or local max, I have that at t equals 1 because v of t changes positive to negative. Now, if they ask for relative mins and maxes, do I also have to list that 8 was a neither? No. If it said find all critical numbers, would I have to list 8? Yes, but it doesn't, so we don't have to do it. Okay, last part, part E. Find v of 0. And then it says, is the particle traveling towards or away? What am I going to need besides v of 0? X of 0. Very good. Okay, now, what is my graph of? What's in my graph? Velocity. So if I want to know the velocity at 0, I'm going to use the graph. So look at the graph. At 0, what is velocity? At 0, what is the velocity? 4. That's the y value. Right? Because what is this a graph of? Velocity. So if I want v of 0, I need the y value, which is 4. Yes, ma'am?
The problem says at time t equals 0,
Perfect. Okay, look up here. At time equals 0, that's the other piece of our information. Okay, the particle is 6 centimeters above the origin. Did they tell you velocity? They told you position. What is x of 0 if I'm 6 above the origin? Is it positive 6 or negative 6? Positive 6. So they gave you the position. This is a graph of velocity. So it almost kind of seems like for a second, wait, it's supposed to be 6. That's position. This is velocity. So I'm going to come down here and put, okay, then v of 0 is 6. Now I'm moving along the y-axis. So let's draw a picture here. So here's my axis. Where do I start at, it says? Position is 6. 1, 2, 3, 4, 5, 6. And then my velocity is 4. Which way am I traveling, up or down? It's a positive 4. That tells me I'm traveling up. If it had been negative, which way would I have been traveling? Down. So if I'm already above and I'm still going up, then am I going towards or away? Away. Very good. So I would say v of 0 greater than 0, particle traveling to the right. I'm sorry, particle is traveling up. And x of 0 greater than 0, so already above origin. therefore away from origin. Because I'm already above, and then I'm continuing to go up past that point. Make sense? Okay, if you're on the AP test, you can draw a picture, but that does not count as a justification. So if I had to eliminate one of these, you have to eliminate the picture and do the words. Okay, which I know nobody likes, but that's kind of the standard. Okay? So there are 3 things that you can be working on. Okay, thing number 1 would be working on homework 1, which is over this topic. That is due on Friday. You could also work on your quiz from Friday, okay, which is also due on Friday. Or you could work on homework 17. Okay, so unless you are the most responsible student ever, you have something to work on. Okay, you can pull your desks together, ask me for help, but everybody be productive, okay? You can do it.